Hello student, let us start standard 12th chapter 1 relations and functions, chapter 1 of 12th standard. This one is our very first lecture. In 11th standard, you already studied definition of Cartesian product of two sets as well as relation. In 12th, we have to see in details. Let us recall that concept from 11th. Cartesian product of two sets. How to define a Cartesian product of two sets? For A not equal to phi, B not equal to phi, Cartesian product of A and B is denoted by A cross B. This is the notation. And define as A cross B is equal to order pair AB, where first element from set A and second element from set B is a Cartesian product of two sets. Initially, that should be non-empty sets. Now see here, if number of A is equal to M and number of B is equal to N, then number of A cross B, we are familiar with this form, NA into NB is equal to Mn, total number of elements, and total number of subsets of A cross B is equal to 2 raised to n of A cross B is equal to 2 raised to Mn. We got the total number of subsets of A cross B. Clear? This is the concept of Cartesian product. Let us consider A is equal to 1 to B is equal to order pair. So set AB. Then have we defined, for example, Cartesian product 1, 2 cross AB. That is nothing but order pair 1A, 1B, 2A, 2B. Clear? Now say this is the Cartesian product of two sets A and B. And this is the one of the example. Now our aim is to see the definition of relation. See, for A non-empty, B non-empty, any subset of A cross B is called, any subset of A cross B is called relation from A to B, and it is usually denoted by capital R, because first letter of relation is R, so usually they are denoting by R. That means any subset of A cross B is called a relation. But one note, if for A not equal to 5, for any single set 1 is given to us. If for A not equal to 5, for A not equal to 5, any subset of A cross A is called relation on set A. That is the relation on set A. Now see here, if R is relation on set A, R is relation on set A, then this can be written in notation of X or Y for all xy belongs to A, or order pair xy belongs to R. Clear? And that should be for all xy belongs to A. This is the notation. Clear? This is the notation for relation. For example, A is equal to, let us consider 1, 2, and let us consider R is equal to one relation 1, 1, 1, 2, 2, 1, 2, 2. Consider this set. It is a subset of A cross A and is a relation. Now see here order pair 1, 1 belongs to R, that means 1 R 1. 1 2 belongs to R means 1 R 2. 2 1 belongs to R means 2 R 1, and here 2 R 2. Either we can write in notation form or we can write it in order pair. So this is the example to see the relation. That means any subset of A cross A, for non-empty set A, any subset of A cross A is called relation on A. Now our aim is to see the types of relation. In next page, first of all, types of relation, first one, reflexive relation. Reflexive relation. Let us define it. Suppose R is any relation on A. R is any relation on A. Once again, let us see. R is equal to order pair 1, 2. R is equal to 1, 1, 1, 2. R1, R2, consider 1, 2, 2, 1. R3 is equal to consider 1, 1, 2, 2, 1, 2. R4 is equal to 1, 1, 1, 2, 2, 1, 2, 2. Clear? Now see, in case of R1, 1, 1 is there, 1 R1 is there, but 2 R2 is not there. Here 1 R1 or 2 R2 is not there. Here 1 R1 is there, 2 R2 is there. Here also 1 R1, 2 R2. That means if for all x belongs to A, x or x, x is related with x, then such a relation is called reflexive relation. If order pair XX belongs to R for all x belongs to A, or x R X for all x belongs to A, then R is called reflexive relation on A. Now see here, this is gone set A, we are defining relation R1, 1 1 is there, but 2 R2 is not there, so this one is not reflexive. This one is not reflexive because 1 1 is not there, 2 2 is not there. Here 1 1, 2 2 both are there, so it is reflexive. R4 is also reflexive because 1 1 and 2 2 is there, and set consists only 2 elements. So this satisfies this condition here. So this type of relation is a reflexive relation. That means element itself is related. Every element of given set A is related itself with A, X. Then that relation is called reflexive relation. So this is the type of first relation, reflexive relation. For example, if we would like to, we can mention it. A is equal to 1, 2. R1 is equal to 1, 2, 2, 1. Here 1, 1 as well as 2, 2 is not in R. And therefore, R is not reflexive. But if I consider X is equal to R is equal to, let us consider R2 is equal to 1, 1, 2, 2, then it is reflexive. R2 is reflexive. Clear? Now next example, if I consider A is a set of residents in a one society, resident of all the members in a particular one society. And I am taking relation R is equal to order pair XY. X is wife of Y. See, relation is X is a wife of Y. So Y is husband and X is wife. X is female, Y is male. Here we cannot say that X are X. X is not a wife of X. So this relation is not reflexive. A reflexive property is not satisfied for this relation. If I say same set, A is a set of residents in a one society. Let us consider one more relation. R is equal to order pair XY. X is brother of Y. X is brother of Y. See, X is brother of Y. Let us consider Manu, Kanu, and Manu, Mona. Manu is a brother of Mona. Manu is mother of Kanu. But we cannot say Manu is a brother of Manu. Manu પોતે પોતાનો ભાઈ થાય, પણ જો ગર્લ્સ હોય તો એ ના થાય, કારણ કે X is a sister of X થાય, તો આ relation reflexive ના થાય. It's not a reflexive relation. Next relation, that is second one, symmetric relation. See, suppose R is any relation on set A. If X are Y implies Y are X, for all XY belongs to A, then R is called symmetric relation. Symmetric relation on set A. For example, see here, A is equal to 1, 2. R is equal to 1, 1, 2, 2. R2, R1, R2 is equal to 1, 1, 1, 2. R3 is equal to 1, 1, 1, 2, 2, 1. R4 is equal to 1, 2, 2, 1. Here 1, 1, 2, 2. X is equal to y. Here also x is equal to y. So this condition fulfills directly. So this relation is symmetric relation. 1, 1, so that is satisfied. 1, 2 is there, but there is no 2, 1. 2, 1 is not in this set. So R2 is not symmetric. R1 is symmetric. Here 1, 1 is there, 1, 2 and 2, 1 is there. So it is symmetric. Clear? Here 1, 2 and 2, 1 is there. So it is symmetric. That means whenever order pair XY is in relation, then if the order pair YX in that relation, then that is symmetric relation. Clear? This is the example. Take care. Now one more relation is there, third one, that is also important for us, but as far as our textbook is concerned, not much more important this relation, but for JEE exam it is important. Skew symmetric relation. Skew symmetric relation or antisymmetric relation. Suppose R is any relation on A. If X are Y and Y are X implies X is equal to Y. That is, X is related with Y by relation R. Same time Y is also related with X, same relation R. If this two condition is there and if we can prove X is equal to Y, then R is called skew symmetric relation. Skew symmetric relation on A. For example, consider A is equal to A comma B belongs to power set of U, that means both are sets. A or B implies if and only if A is subset of B. I am taking relation subset relation as a subset of a set. Now A are B and B are A. This implies A is subset of B and this implies B is subset of A. A is subset of B, B is subset of A, so equal to B, yes or no? Yeah. So this subset relation is skew symmetric relation. One more example, R is the set of real number. For xy belongs to R, let us take relation as x as y if and only if x is ordinary less than or equal to y. If x is less than or equal to x or y and y or z, means x is less than or equal to y and y or x, means y is less than or equal to x. This thing is happen only when x is equal to y. So this less than or equal relation is also skew symmetric relation. But see, x less than or equal to y, not necessarily y less than or equal to x, because 1 less than 2, but 2 is not less than 1, so it is not symmetric. A is subset of B, not necessarily B is subset of A. So this relation is also not symmetric. Both are not symmetric, but both are skew symmetric. Clear? See, this is the concept of symmetric relation and skew symmetric relation. Now our aim is to see one more relation. See here, fourth one, transitive relation. Next relation is transitive relation. See, suppose R is any relation on set A. R is any relation on set A. If for all x, y, z belongs to A, x are y and y are z implies x are z, then R is called transitive relation. On set A. For example, let us consider A comma B belongs to power set of U. A or B, if and only if A is subset of B. Now see, A or B and B or C, if both are given, then we have to check for A or C. See, this one is given. If these two conditions are then and only then we have to check for this one. If any one of them is not there, then we have to accept without proof that is the transitive. That thing we have to check only when both are there, then we have to check this thing. Keep that thing in mind. Now see here, A or B means what? A is subset of B. B or C means what? B is subset of C. And we know that A is subset of B and B is subset of C. Then A is subset of C. So A or C. So this relation is transitive relation. For example, let us consider A is equal to 1, 2. R is equal to 1, 1, 2, 2. Then x are y and y are x, y are z, but x or y is not there, only 1, 1 xx is there. Xx comma xx in R implies xx is also in R. So they satisfy for condition 1. 1, 2, 2 comma 2, 2 in R, so implies 2, 2 in R. 2, 2 in R, 2, 2 in R implies 2, 2 in R. 1, 1 in R, 1, 1 in R implies 1, 1 in R. So this relation is transitive relation. But if I consider R is equal to 1, 2 and 1, 1. So 1, 1 that is x belongs to R, xy belongs to R. Implies xy belongs to R is there? No. Now see 1, 1, 1, 1, 1, 2. 1, 1, 1, 2 belongs to R. Implies 1, 2 belongs to R? Yes. Is that? So it is a transitive relation. R is equal to, if I take only 1, 2, then is not a of course, is a transitive relation. But if I take A is equal to 1, 2, 3 and R is equal to 1, 1, 1, 3, 2, 3 and 3, 2. Consider. Now 2, 3 is there, 3, 2 is there. So, but 2, 2 is not there. X or Y, Y or Z, but X or Z is not possible. So, this relation is not transitive. Ultimately, what we have to check? Whenever X or Y, whenever X or Y and Y or Z given to us, then we have to check it, this thing. For example, consider A is the set of resident in a particular one society. Let us consider order pair XY. X is wife of Y. X is wife of Y. Now see here. X is wife of Y. Then Y cannot be wife of any other person Z. Because if X is wife of Y, then Y is male, and male cannot be wife of any other person. So X or Y is given, but Y or Z is not given. So there is no need to check X or Z. If these two conditions are there, then we have to check it. If any one condition is given, other one is not given, then we have to accept that it is a transitive. So this relation is transitive relation. Clear? Now let us define one more relation, and that is most important relation for us. Equivalence relation. Equivalence relation. Suppose R is any relation on set A or any set X. R is any relation on set A. If R is reflexive, symmetric and transitive on A, then it is said to be equivalence relation on set A. Now see, for example, A or B, consider relation is A is subset of B. Clear? Then A is subset of A is possible, but A is subset of B, then B subset of is not there. So it's not a symmetric. So it's not a transitive relation. But if I consider L is set of all lines in a plane, L1, L2 belongs to L. L1 related with L2 if and only if L1 is parallel to L2. Here we are taking relation is parallelity of two lines. We know that line itself is parallel to itself. So reflexive is there. If L1 parallel to L2, then L2 is also parallel to L1. So symmetric is there. If L1 parallel to L2, L2 parallel to L3, then L1 is also parallel to L3. So transitive is there. So this relation L1 parallel to L2 is a equivalence relation. Let us consider one more relation on same thing. L1, L2. L1 is related with L2 if and only if L1 perpendicular to L2. A line is perpendicular to other line. A line itself is not perpendicular to line itself. So it is not a reflection. If L1 is perpendicular to L2, then L2 is also perpendicular to L1. So it is symmetric. L1 perpendicular to L2 and L2 perpendicular to L3, it is not necessary that L1 is perpendicular to L3. So it is not transitive. So this relation is not equivalence relation. Clear? Now see, let us see up to this set what we done. First of all, how to find a Cartesian product of two sets, that we know. How to check the reflexive relation. R is any relation on set A, and if XX belongs to A, or XX belongs to R, or X R X for all X belongs to A, then it is said to be a reflexive relation. And one more thing, when we say that it is a transitive relation, symmetric relation, if XY belongs to R implies YX belongs to R, then it is a symmetric. And one more thing, X are Y and Y are X implies X is equal to Y, then it is a skew symmetric relation. Clear? Now X are Y, Y are Z implies X are Z, then that relation is a transitive relation. Any relation is reflexive, symmetric and transitive is called equivalence relation. Clear? Up to this stage we seen this thing. Now one more definition, equivalence class. Equivalence class. We can find equivalence class only when a equivalence relation on a given particular set is given to us. Suppose R is an equivalence relation on set A. Equivalence class of any element of a given set A is denoted by square bracket X. Keep thing in mind, only for chapter number 1, the square bracket X denote equivalence class. Otherwise, it is the greatest integer part function in a rest of mathematics. So, as far as chapter 1 relation and function is concerned, square bracket X stand for equivalence class and is defined as equivalence class means all those elements of set A such that they are related with X. This is the equivalence class, and that thing we find only when given relation is an equivalence relation. Clear? Now dear friends, let us start exercise 1.1 NCERT. Exercise 1 from NCERT. See, exercise 1.1 from given relations, check whether they are reflexive, symmetric or transitive. That means we have to check whether they are symmetric, reflexive or transitive. That thing we are going to see. See, first one, set A is set of positive integer up to 40 and a relation on set A is R is equal to order pair xy 3x minus y is equal to 0. This relation is given to us. Now we have to check it whether it is symmetric, skew symmetric, transitive or whatever may be. Here, see this is the given in question. Now this one is the answer. How to write in a board example? See here A is equal to 1, 2, 3 up to 14. Clear? And R is equal to order pair x, y, 3x minus y is equal to 0. Order pair x, 3x, x belongs to A. Why? Because y is equal to 3x is there. So list out element. If I take 1, then it comes out 3. If I take 2, then it comes out 6. If I take 3, then it comes out 9. If I take 4, then it comes out 12. But if I take 5, then there is 15. And 5, 15 is not in A cross A. So only those elements of A cross A satisfy this equation. Satisfying this equation are the member of relation. So here this relation R is there. Now we have to check. Here 1, 1, 2, 2 and 3, 3 is not in R. Means X or X is not possible. Or order pair XX is not in R. So that's why it is not reflexive. Therefore, R is not reflexive on A. Is not reflexive on set A. Clear? Now see here. Next. Here. See, 1, 3 is there, but 3, 1 is not there. 1, 3 belongs to R, but 3, 1 is not in R. It is enough to give one example. Same way 2, 6 is there, but 6, 2 is not there. 3, 9 is there, but 9, 3 is not there. 4, 12 is there, but 12, 4 is not there. Therefore, similarly, 6, 2, 9, 3, 12, 4 are not in R, and therefore R is not symmetric. This relation is not symmetric relation. Same way, next condition we have to check here. See, also. See, 1, 3 and 3, 9 both are in R. What is the definition of transitivity? If X are Y and Y are Z, then we have to check X are Z. Here X are Y and Y are Z is there, but 1, 9 is not in R. And therefore R is not transitive. Clear? Today we are going to see up to this stage. In next lecture we are going to see that thing. Homework, I would like to give a homework exercise 1.1, example number 4, subpart 2, 3 and 4. Try yourself to check it whether they are symmetric, reflexive or transitivity is there or not. And same time try to see illustration number from 1 to 6. Just try. Later on also we are going to see these illustrations also. Clear? Thank you, dear friends. Take care.